Yo, what's up, you turds? Yeah, I have COVID right now, and this is how I'm going to be choosing to spend my time. Yay! Now, I trust that everyone's going to be listening to this recording and studying very hard for their chapter test, right? Yeah, and then everyone clapped. Okay, let's get started. Use the diagram to answer the following questions. The first question asks, what is another name for MN? That's a segment because that has just one line on the top, MN, this guy right here. Well, MN is going to be this segment right here. Remember, when it's a segment, it's just a straight line on top. You can read it from left to right or right to left. So the direction does not matter. In which case, literally, we can just call it NM. Ooh, let's use a less scary color, NM. And these are two different ways to be able to express this line that I'm highlighting, this line segment. If we look at the next question, though, this one says one arrow. Okay, notice I'm going to really emphasize it here. It's going in one direction. It's pointing from K, starting from K to the L direction. So K to L, meaning it has to start from that same point K and go in the same direction as L. And we want to find another name for a ray that does that. Well, let's quickly use our handy highlighter, KL. Well, which one starts from the same point and goes in the same direction so that if you were to take this guy, eventually it'll line up with the same exact ray? Well, playing a little bit of Dora the Explorer here, I would assume you answered correctly. It's KP. KP. I apologize if the color coding bothers anyone. I have COVID. I don't care. All right, there you go. KP. And again, two things that mattered here. You care about the start point, and then the second thing was that same direction. Okay, just keep that in mind. That's how we got this. We can't just flip KL. If we just flipped KL, that would mean LK, but that would be going in the wrong direction, and that's not what we want. Okay. Okay, let's look at the next one. The figure below is a rectangular shipping box. Choose two different planes that contain this line segment MP. Okay, so this one's an interesting one. We're going to have to use process of elimination, boom, 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 and then hopefully arrive at our answer, which, spoiler alert, I believe is actually C. Well, let's take a look. Read this first question, plane LMN and plane LMS. You really have to understand what are they asking you. So if they're asking you something about MP, they're asking you, does the two planes contain that I just highlighted it, does it contain that line segment? Well, let's see whether or not the points that we're going to highlight do. And so this first one is LMN, okay, LMN. So which plane contains LMN? Well, those 3 points. Well, it's clear to see, and I know K is not written, but technically that guy's included. That top plane is the only plane that contains the points LMN. Well, what about the next one, LMS? LM and then S are these three right here. Well, that's going to be this plane on the side right here. Now, do these planes contain both? Do they both contain MP? Well, if you take a look, this top plane does not contain the line MP. Okay, this one might do it, but unfortunately the top one does not. So really what all they're asking you is, does it satisfy it? No, this does not. Okay. We're gonna have to do this a couple times to see which one of these answers actually makes sense. Let's do the next one. So NQP. This one's N, this one's Q, and this one's P. Well, technically that is going to be this plane right here, right? I know M's not included, but again, it includes it. And then we have N, wrong one, KQR, K, Q, and then R, KQR, wait, KQR, wait, what? I'm confused. Oh, that's not R. So sorry. K, Q, and then R are going to be those 3 points. I know it's a little bit hitting in the back. So again, these guys are going to be the planes. And the question is, again, does it contain this line MP? And you can clearly see that the blue shaded region that I just marked, that one does not contain that line. So unfortunately, this answer is also off the map. Okay, sorry for the little bit of confusion there. And then let's try the third answer. I'm going to tell you right now, this one is going to work. Let's see why. So LMS, points LMS are going to be the one on the side right here. Boom. If we look at the next one, NQP, well, NQ and then P are those three. So that's going to be this plane right here. Well, again, the question asks, do these two planes contain MP? Turns out this one borders both of them, okay? This left side and then this right side. They share that little line segment, okay? So kind of a neat problem. Turns out this is our answer choice. These two do actually contain the line segment, okay? If you do the last one, you'll also see that doesn't work. Okay, so measure the length of MN to the nearest tenth of a centimeter. Okay, this one's pretty easy. Literally, as long as you have 1/10 of a brain, you should be able to solve this one. This is 1, right? This length is also 1. This length is, let's do a little smaller. This length, if you just really zoom in, it's about 0.6 or 7. I'm gonna be a little generous here, say it's 0.7. That's going to be roughly about 2.7. And depending on the multiple choice questions, trust me, the answers are going to be pretty different from one another. So there's no way you're going to end up getting this wrong. Okay, 2.7. Just make sure you know how to count using a ruler, right? This is one length. And then this is 2. And then, yeah, why am I spending so long? All right, goodbye. All right, here's the next one. Find FH. Always read the problem. This is what they're asking you to find. So they tell you that the total is 42 and that this part of it is 22. Well, that means that this one and this one technically need to add together to equal the total amount. That's 42. Or if you want to think about it another way, the total length subtracted by that partial length should give you whatever the highlighted part is. And so if you can do any sort of basic addition or subtraction, you should end up with 20. And that's going to be your FH value. Okay. Moving on. So number 6, point M is the midpoint of RS. Find SM. So I'm going to highlight SM. Remember, you could read it from left to right. SM is just this guy right here. Okay. We want to find out what is the length of that. And right now it's just a variable expression. We do need to find our X value so that we can plug it in. Well, if we know that this is the midpoint, right, that's the middle of those two line segments, then we know that this left side must be equal to the right side. They must be the same exact length. That's just the definition of the midpoint. So let's set them equal. Okay, that's what's going to happen here. Let's make our way downtown, walking fast, faces pass. All right, forget it. Minus 3x, subtract. This is going to cancel. You're going to get 3x minus 2 equals 7. Add 2 to both sides. This cancels. You're going to get 3x equals 9 divided by 2. Oh, that's not 2. I have COVID. Forgive me. My mind is not right. Okay. Question, students. Is this your answer? No. We're trying to find SM. We have to plug it back in. Okay. So whatever SM is, and remember, the equation is going to be 3x plus 7. Let's plug it back in. And so that is going to give us 3 times 3. That gives us 9 plus 7. That should give you a total of 16. Okay. And so that is your answer. And did it matter which equation you turn it into? Plug it in? Not really. I mean, this is how you check your answer, actually. If you plug it back in to this other equation, you should also equal 16. Okay, and you have my word that if you were to do that, you do get 16 because, again, at the end of the day, it's the midpoint. Both segments on the left and right should be equal to each other, congruent. Okay, let's look at number 7. A couple things here. We're told that this measure of angle 1, is going to be 3x plus 10. Okay, so I'm going to just write that in. This is 3x plus 10. And then this length right here, I'm going to color code it something different. This is going to be PWX. So PW to X. So PWX is going to be 8x plus 6. And when it says this is an angle bisector, it means this cuts it in half, which means, again, this is the same type of problem as above, right? It's directly in the middle. These two must be equal to each other. That's what they're saying. If it truly cuts it, if it bisects it in the middle. So let's solve this. Again, forgive me for my poor color coding here. But all I'm doing is setting those two angles equal to each other. And then you can solve it however you want. Again, it doesn't matter which variable you subtract first, or if you do the numbers first. Again, you'll get the same answer. 10 equals 5x plus 6 minus 6 minus 6. You're going to end up with 4 equals 5x. I know, this one's kind of a weird one. Divided by 5. Oh, and what do you know? You get x equals 4 over 5 as your answer. Now, is this our answer? Well, actually, yes, it is. This time, all they asked us to find was x. And so, rejoice, this is your savior. Get a weird little fraction answer. You could check your answer to see if you got it right by, let me hop to the actual answer key. You could totally plug it back in. Notice that we got the same answer as what the answer key tells us. If you plug it back into either side, at either angle, you'll get the same exact length. And that's how you know that this truly was an angle bisector. It cuts it in half. Okay. Let's imagine if this problem said something else. For example, if this said YWX, okay? Now what would this be saying? So angle 1 would still be this guy that I'm highlighting, right? So that's going to be, let's call it 3x plus 10. But then this time, well, this is going to be interesting. You would have the whole angle YWX, this whole thing would be equal to 8x plus 6. Now, here's the thing. This doesn't help us too much. We want to know what is the angle, what is the measurement of angle 2? This is the guy that we want to find. We don't know what that angle is, because then we can set it equal to each other and solve for x. Well, if we know that this total length, if this total length is 8x plus 6, well then we know that half of that should be 8x plus 6 divided by 2. It should be cut in half. And here's what I mean. Think about it. If you have 8x plus 6 and you cut it in half, right? You cut it in half. Well, then you're going to end up with just angle 2. So if you divide that angle in by half, well, that's going to give you 4x plus 3. Turns out this is going to be the angle measurement for 2. Okay. In fact, let me clean this up a little bit. We know that according to what we just found, measure of angle 2 is going to be 4x plus 3. And so our actual angle that we're going to set equal to each other is going to be, let's clean this up, is going to be these two. Okay. So let's do that. I know this is a little bit messy. If you set them equal to each other now, because you know that those two angles are equal to each other, because again, it's cuts in half right here. Then you can solve this like normal. Subtract 3x, subtract 3x. You're going to cancel this out. You're going to end up with 10 equals x plus 3. Subtract 3, subtract 3. You're going to end up getting 7 equals x, and this time the answer is a little bit cleaner. Okay. Yeah, weird problem. You do have to think a little bit outside the box here. Hopefully we will cover this a little bit more next time, but for the time being, this is kind of how you would do it if this was to arrive on a test. Let's jump back. This is the midpoint. Midpoint, always read which formula they want you to apply. They want you to find the middle of these 2 points. And so again, let's apply our formula. This is going to be the 2x values, and then cut it in half. Let's move this guy a little bit. And then you're going to take the two y values and cut that in half. And that's how I want you guys to think about the formula, by the way. Don't just memorize it. They're dividing by 2 because it's taking the average of the 2 points. Well, remember, this is x1, this is y1. This is x2, this is y2. And so we just need to plug in these numbers correctly. Take the average. These two need to go here, -4 plus 5, right? So let's do that. Again, the bottom one's always going to be 2. If you plug it in, this is going to be -4 plus 5. And then again, you're going to get y1 and then y2. That's 5 and -3. 5 plus -3 is just 5 minus 3. And then at this point, just simplify. -4 plus 5 gives you 1, and then that's 1/2. 5 minus 3 gives you 2, divided by 2. Well, that's just 1/2, comma, 2 divided by 2 is just 1. If you wanted to write it in decimal form, it actually would be beneficial if you were graphing it. That would be 0.5 or 0.5 comma 1, or just you could keep it in fraction form if the answer asks for that. 1/2 and then 1. Again, remember the concept between that. It just means that those two are going to be, this point is going to be in between those 2 points. Okay, find the other endpoint of the line segment with the given endpoint and midpoint. Okay, this one is a little bit different. Again, you can skip this one if I've given you permission in class. But again, this one tells you the midpoint formula, remember, is going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2. And the thing about this one is they already gave us the midpoint, okay? In fact, what they did give us is x1, y1, and then this is going to be the midpoint. So literally, these two are already given for us. They should, if we solve this for later, this is going to be equal to 0, this is going to be equal to 1, according to what we've highlighted above, okay? Now, here's the thing. We already know what x1 and y1 is, but they're asking us to find what is the other endpoint. That is, what is this one and what is this one, okay? This is the question mark, this is the question mark. So what we're going to do, let's take a look at this. This is going to be an interesting problem. x1, let's just replace it for that, okay? Goodbye. I'm going to plop this guy there. And then y1, goodbye. I'm going to plop this guy there. So what we're doing is we're going to take -6, plop it down there. We're going to take 3, plop it down there. Okay. So let's write down -6 and then 3, plop it down there. So if we want to consider how to write this equation, I am going to write, I might work a little bit to the side here. Let's rewrite what we have on the left side. Okay. So what we're going to do is we're going to write this first, okay? Let's rewrite -6 plus x2, let's just call it x, divided by 2 is equal to 0. And then let's write 3 plus y2, let's just call it y, divided by 2 equal to 1. And here is how it's going to help us out. Let's cross multiply. Multiply by 2, multiply by 2. What that's going to help us do is these are going to cross out. And then that's going to give us -6 plus x equals 0 times 2, which is just 0. Add 6 to both sides. Turns out your answer for x2 is going to be 6. Okay, just bear with me. Hopefully it'll make sense in just a little bit. And if it doesn't, come talk to me. I can help. Okay, you're going to cross multiply by the fraction on the bottom. Okay, so that they cancel. You're going to end up with 3 plus y equals 1 times 2. That's 2. Subtract by 3, subtract by 3. These are going to cancel out. You're going to end up with y equals -1. And again, we were really solving for the x2 and the y2 values. I just got rid of them just to make it simpler. So it turns out your second endpoint is going to be 6 comma negative 1. Okay, and if you have no idea what we just found, again, all it's saying is if you took this endpoint and this endpoint and you use the midpoint formula, you would be able to get this guy right here. Okay, this guy right here. And you can verify that, trust me. Basically, this problem, what it does is it reverse engineers the problem that we had from before. It's not so simple. We have to actually find the middle. We're already given the middle, and we want to find the other endpoint. Okay. This is a little bit difficult to convey unless we've gone through this in person together. So please come by my room, and then I can try to re-explain it if you don't understand it. Okay. All right. Number 10. Find the distance between each pair of points. Okay, again, read the question, distance. You want to be able to round to the nearest tenth, so I'm going to highlight that too. So again, x1, y1, x2, y2. First pair of points, and then second pair of points. That's how I remember it. So our distance formula, again, you should try to commit it to memory. It does come up a little bit later in the other classes. Okay. In fact, I messed up here. This is going to be x2 minus x1, and then y2 minus y1. That's the standard form of how you would write that. Again, the easiest way I like to do it is I write the skeleton of the formula, like I like to call it. Okay, I know the skeleton of the formula is just what I need to plug in. So let's quickly look at the numbers I need to plug in. x2 and x1 should go in here. So let's do 2 minus 4, no double negative there. And then y2 minus y1, that's going to give you negative 3 minus 3. That's going to give us negative 2 squared plus negative 6 squared. Careful with your negatives. Now, negative 2 squared, this guy right here, be very careful. That gives you a positive 4, right? Think about it. Negative times a negative is a positive. So that gives you a positive 4. And think about this one, negative 6 squared, that gives you a positive 36. The negatives cancel out. That should give you square root of 40. And if you wanted to do some crazy math simplification, you know that square root of 4 comes out. That's 2 square root of 10. On a calculator, again, you don't need to do any of that. If you want to skip this whole step and just plug it into a calculator, you should end up with 6.324 dot dot dot. Or in short, you'll get 6.3. This is the rounded version, okay? And again, we rounded that from 6.3 to 4, dot, dot, dot. By rounded, I mean we just cut off the decimal. We didn't actually need to round here. Okay, that's the distance between the 2 points. Let's look at this one, number 11, solve for x. We have this section right here and this section right here. Well, think about it this way. If you have 2 sections and they need to add up to the total length, which is given by this equation, well, it's as simple as just adding those 2 values together, okay, and equaling it to the total. So 3 plus 5x plus 1 equals 8x minus 2. Notice that these two are like terms. That becomes 4, right? And so let's write 5x plus 4. And again, the way we got that was we saw that these were like terms, right? Equals 8x minus 2. Subtract by 5x, subtract by 5x. This is going to cancel. 4 equals 3x minus 2. Add 2 to both sides. 6 equals 3x divided by 3 divided by 3. And again, this should give you 2 equals x. We're just solving equations. Hopefully nothing too crazy here. And honestly, that's all they asked for. That's all we need to find. Read your questions very carefully. Measure of angle PUV equals 42. I'm reading this top right here. And measure of angle TUP is equal to 135. So again, 2 things here. 42 is going to be PUV, this guy right there. And then TUP is going to be this guy right here. Okay. So let's fill that in. They say they say PUV is going to be 42, and then they say TUP is going to be 135. Well, how do we find what they want us to find? They're asking us to find measure of angle TUV. So highlight it if you have a highlighter. TUV is going to be this guy. Well, think about it. That's just this total angle added up. Super simple, right? That's just going to give you 177. And again, that's just 135 plus 42. All right, nothing too crazy. Just read the question. Find the value of x. Okay, first thing I want to tell you, you can ignore all of the extra lines here. Does not matter. Okay, all we need to know is what exactly is the angle that they're giving us. And it's pretty clear to tell by this square, although if you can't tell, this guy means 90 degree. This forms a 90-degree angle, which means these two need to add together to equal 90. So let's do that. 45 plus 3x equals 90. Find x. That's the goal here. I'm going to zoom out. That's going to give us 3x equals 45. Again, quick maths. Divided by 3, you're going to get x equals 15. That's going to give you the answer. And again, check your answer, plug it back in. Does that give you 45 and 45, which adds up to 90? Yes, it does. Okay, this one's a vertical angles problem. Vertical angles. Remember, if you have vertical angles, you form this little x. Well, everything that's across from each other are the same. They're equal to each other, okay? So I'm going to highlight these two angles. Remember, vertical angles are congruent. So because they're congruent, just set them equal to each other. It's really as simple as that. You have a nice little equation to solve. Okay, and by nice, I mean super, super easy. 3x equals 78. I know, weird number. Go ahead and plug that into a calculator if you need to. Divide by 3, divide by 3. You are going to end up with x equals, not 2. Oh, no, I am right. 26. Okay. And again, plug it back in. Check your answer. Okay, coming down to the end here. Again, this one, find the value of x. So all we need to do is find x. Don't go crazier than you need to. Just read the question. This one is asking, again, you could ignore everything else. Just look at what angle they're giving us. They gave us two angles. Well, clearly, if you ignore everything on this side, these two need to add up to 180, right? This is a straight angle or a supplementary angle. So doesn't matter which order you write the equation. Again, just it'll get the same answer regardless. The key step is, again, these need to add to 180. So set it to 180. Let's combine like terms. So again, maybe I'll demonstrate a little bit more clearly this time. These two are like terms. So you're going to end up with 5 plus 7x equals 180. Subtract 5, subtract 5. You're going to end up with 7x equals 175 divided by 7. Again, kind of a weird number. And because I've done this already, I already know the answer is 25. Okay, coming down to the end. Find the area of the sandbox. Okay, if you're pressed for time, just read what they're asking you to find. Really, everything else is just context clues. They gave us 4 coordinates. This one's already nice. It's already nicely labeled for us. The one comment I want to make is read the grid marks, okay? These are written in 2 units, okay? So each of these is written in 2. So this is 2 units, 2, 2, 2 units, okay? For a total of how many units? 8 units. Okay, I don't know if they gave us units here. Oh, 2 feet. So I guess we can say 8 feet. And then if you want to calculate the other side, again, this is also in increments of 2. Okay, don't just jump into the battlefield without knowing what you're, I guess, jumping into. That metaphor kind of fell apart, but that's okay. This one is 2, this one is 2, for a total of 4 feet. Okay. Oh, that's terrible. These two 8 feet, 4 feet. So what is area? You want to find the area of this? Well, it's a rectangle. That's length times width. Length is going to be 8, and the width is going to be 4. So that's just 8 times 4. That gives you 32. 32 what? Well, remember, it's feet times feet. That gives you feet squared. Okay, I'm going to just write that in short. 52, or FT squared. All right, and then remember, area is always squared. Convex or concave? Let's speed run this. Remember, concave, I think of it like it caves in. Does it cave in? Does it create this little tiny ridge? Let's see. If you were to draw a line, line, does it cut through the shape? No. So this is clearly not concave. It does not cave in. This is convex. Simple as that. Ding. Convex or concave. Okay, let's try that test again. Does it cave in? No, no, no. Oh, it does, right here. Let me erase it again. Boom. Notice how it caves in here. This junction right here, it caves in. So this is concave. Okay, it caves in. Okay, is anyone paying me for this?